All right, hello and good afternoon, everyone. Welcome to our session today. Thank you for coming out. My name is John Brock, and I'm a product manager here at Salesforce. I manage the enterprise messaging platform team, which owns platform events and our streaming APIs, and I also am in the PO for change data capture. So really excited today to talk to you about CDC. This is one of the most talked about features, I think, this Dreamforce and even last Dreamforce. A lot of internal teams are building on top of us on features that you don't even realize uses CDC, but we're really excited to bring this to you, our customers, and have this externally exposed. So really excited to hear what you're going to be building with this, and really excited for you to test this out and really try it out, and let us know how you're using this. So today we're talking about synchronizing data and orchestrating workflows in real time. So we're really going to dive in on how do I capture Salesforce record changes and take action in a different system and really orchestrate those real-time interactions related to that data. Forward-looking statement, as always, change data capture is not GA today. It is available in pre-release orgs. So if you sign up a DE org today, you will be able to try CDC. We're targeting for a mid-winter 19 release, so that's just around the corner, but it's not GA, so please only purchase based off of what we have available today. So change data capture at a high level. The goal with this feature is to capture all Salesforce record changes within your org. So whenever something's inserted, updated, deleted, or undeleted, I want to publish an event for you to process and either do a data synchronization or kick off a dependent downstream workflow. A few of the advantages here is that you can rip out all of your Apex trigger change detection code. You don't have to maintain that. You don't have to have that inside your transaction, slowing those transactions down. We basically have instrumented at the lowest levels of our save layer, and in our database, these change capture triggers that record at a very granular level all changes happening to your Salesforce data. And then finally, if you attended my platform event session, this is a continued push into the event-driven integration pattern space. So rather than having coupled integrations with point-to-point callouts or point-to-point interactions based off of data changes, we publish these change events to the stream, and then any downstream consumer can subscribe to that stream and receive that event in real time. So a few advantages of this are no polling, so I don't have to ask Salesforce every 30 seconds, what accounts have changed? What contacts have changed? Wait 30 seconds. What accounts have changed? What contacts have changed? That's not efficient for you on your implementation, and it's not efficient for me on my Salesforce infrastructure to support all those polling requests. Additionally, you can rip out all your ETL batch processes. You don't have to run a nightly workload at midnight to pull out all data, analyze the changes, and then load it all back in. Right? This is a real-time event-driven stream. We publish those event changes as they're available right when they're happening. Additionally, the event-driven model versus the point-to-point interaction is really where we're trying to push our customers' architecture and what we're trying to evangelize from a Salesforce point of view. So on the right, you can see just a quick example. I'm inserting an account into Salesforce with the name Acme. I'm publishing that insert event to my event bus. In this case, I'm publishing to the data change events channel. That's the fire hose of all data changes from your Salesforce org. And then I have two subscribers, AWS and SAP, receiving that change event in real time. So I've been working with, first off, any pilot customers? Have I been working with anyone in this audience? So I've got about 100 pilot customers that I'm working with every single day, capturing use cases, working through the kinks, and making sure we're delivering a great product to you when we GA. And the three main use cases that we've identified can kind of be bucketed according to this slide. So the first is data replication. As much as I would like to have the illusion that all of you have your master data copy in Salesforce, that's not always the case. Right? Most of the time, Salesforce is a view into your data or a console for you to update your CRM data, and then maybe that's synchronized with an SAP master, an Oracle on-prem solution, or something like that. So this really provides that real-time view into the up-to-date data in that external system because the synchronization happens in real time. It doesn't happen at midnight through a batch process. It's real time right now. If I log into any other system, I see the up-to-date information. The second is process automation. So when I'm a manufacturer and I get an order, I need to kick off downstream workflows or business logic to start the order fulfillment process. How do I do that and not have to pull or not have to wait an arbitrary amount of time? I can do it in real time by subscribing to these change data events. So maybe I receive that in SAP or Oracle, and my downstream business workflow is kicked off because of this change that happened in Salesforce. The third is audit and compliance. So a lot of our FinServ customers in regulated industries have strict requirements on how they need to archive their data, and they need an audit trail of all changes that happen to that data from a particular point in time all the way into the foreseeable future. So how do I archive that data change and those data change steps, intermediate steps, for perpetuity? It's very difficult, but what if I could store all those changes to a data lake and then run my own Einstein analytics over that? Or I could run Redshift analytics and AWS on top of that. If I have these data changes in the data lake, it's now available for me to process and gain insights over. So at a quick level, CDC consists of 3 different parts. The first is capture. Once we capture the change, then we publish that to the event stream. Once it's on the event stream, we publish it out to whoever's subscribed. So in this example, we have an API update updating our account name from Acme to Acme 2. That update happens in Salesforce over the REST API, but it could be the SOAP or bulk API. It could be a UI page, Visualforce component, or a Lightning component, a standard record page. It doesn't matter. We're going to capture that change. We capture that update event from Acme to Acme 2. That change event is published to the enterprise messaging bus. So it's published as a platform event, if you've worked with platform events before, but it's just a very specialized platform event that has a unique shape and specific information about this particular change. And then on the right, you see that our external system is subscribed to that event bus and receives that event in real time so that it can apply that same update change event to its system. So we changed the name from Acme to Acme 2 in that external system. All right, now it's demo time. This is what everyone comes to Dreamforce for, so let's go ahead and jump in. If you have seen the platform events booth or you came to my session earlier, you've heard about Cody. Cody owns a car repair company, and he's implemented best practices on how to build out his enterprise architecture. So before this morning, Cody was using high-volume platform events to be published to notify a part supplier that a part was ordered via a case record. In this case, Cody's iterated, and Cody's ripped out that Apex logic and that process which published this platform event, and he's now using change data capture. So with Winter 19, what you're going to see is this new UI screen for change data capture. On the left, we have all the available entities that you could capture, and this has a list of 23 standard entities. These are the hero objects in Salesforce: accounts, contacts, leads, opportunities. The main objects, plus all your custom objects are supported out of the box. On the right, you see the selected entities. I've selected account, a custom object called printer, contact case, and another custom object called part. So these 5 entities are going to be captured in real time and published to the stream. I might not receive all those events if I'm not subscribed, but we're capturing those internally, and those changes are saved to the event bus for 72 hours. So once my part supplier receives that notification of that change event, that part supplier needs to tell Cody that he's received the part received via a platform event. So we have a platform event here. This references a case ID and the part number that's associated with that change event. And then that part received event is received by a process. So subscribing on platform to platform events, no code here required. We start the process with a part received event. We associate that with the case that's referenced from that event itself. And then we update the status and we post to Chatter. So on the case record, I want to change the status field to part received because I don't want to do manual updates to my data. I want to make sure this is all orchestrated via that platform event. Additionally, I want to post to Chatter notifying the case owner that this part is ready to be installed, so follow up with a service appointment for the customer. But we also have a code option for you on platform, which is Apex triggers. I can write an Apex trigger on that same part received platform event, and I do a few boilerplate things here to collect data, but then in my internal Salesforce parts catalog, which is represented by a custom object called part, I either add it to that catalog or I update the quantity if it's already in my warehouse. So that's what I'm doing here. So now I'm going to switch over to the role of Cody. So Cody has started his day, he's drinking his cup of coffee when he gets an urgent call from Astro. So Cody is going to log a case for Astro and basically try to get Astro on the fast track of making this repair. So priority is definitely high. Astro called us, and then that self-driving component actually failed on Astro's car. So we know that's the CPU 7000, just because that part's been pretty flaky in the past. So we're going to go ahead, put this on the case. That way we can get a part ordered from our parts supplier. Before I log this case, though, I want to log into a Heroku app, listening for all these change data events. So I'm going to log in, and this is Cloudy's parts dashboard. And Cloudy is going to receive all events for the case change event. So we're going to subscribe to that stream, and in real time, we're now going to receive all cases which are updated from this point forward. So what does that look like? Let's save this case. And in real time, we get a CDC event delivered to this Heroku app or AWS app or on-premise app, wherever it's running, in real time, and we have this rich information about this particular change. So because this is a developer session, we're going to dive deep into what this actually contains, because this is really the value of CDC, all this data that we're providing you in this change event. The first thing is the schema ID. This is a very unique fingerprint for the entity that generated this change. This tells me when I receive this event in a binary format, how to deserialize it so that I can have a strongly typed reference to this type change, or this case update, or create, or whatever it may be. Additionally, I have metadata about the change itself. I know that it was a case. I have the record ID. I know that it was a create. The update happened from the SFDC internal API through the Lightning UI that I just showed. If this was your connected app, we would show that here in the change origin field. And then the three most valuable fields here are the transaction key, sequence number, and is transaction end. This is something that you just can't orchestrate today with Apex triggers. Imagine you have an account with associated contacts. So the Astro record has 3 contacts associated with it. When I delete that account, I also cascade delete those contacts. With an Apex trigger, that's very hard for me to capture, virtually impossible. I don't know that those operations happened in the same transaction. With this, though, that transaction key for all 3 of those delete operations, the account and the 2 contacts, have the same transaction key. The sequence number tells me exactly how those were applied to the Salesforce database, and is transaction end tells me my transaction's been committed and it's ready to go. These were all the changes associated with that one transaction, so I can apply these changes in one transaction in an all or none fashion to my downstream system. That way I don't end up with dangling data, orphaned rows, anything like that. And then here at the end, we have obviously all your fields which were updated. This is not a complete view of the record, but it is a delta. So this is a create, so we have all the fields which were created by default. Here you can see part number CPU 7000 came in. And then on the replay ID, that is an indication of exactly where in the event stream this event was generated. So we have a guaranteed strict time-ordered event log that these events are stored to and published. So if I happen to have a subscriber which goes offline for maintenance, or needs to be upgraded, or needs to be migrated, all I have to do is remember this replay ID of that last event that I processed. When I bring that subscriber back up, I use that replay ID, and then I subscribe from all events that I might have missed. And that stream is worth 72 hours, so any event generated for the last 3 days, I can receive and replay. So this is great. About a week has elapsed, and Cloudy received the CPU 7000 part. So we now need to notify our service shop, Cody, that this part has been received. So we're going to publish a platform event back into the Salesforce event bus, and that's going to trigger that process that we walked through just a few minutes ago. So let's go ahead and do that. And we're going to hold on the screen for just a second. So you see in real time, instantly, that process made a change to our case record. You remember that? We were updating the status from working to part received. In real time, you get that update, and Cloudy can now confirm that Cody's received that part in his warehouse and it's been transitioned off the truck, and Cody has now taken possession of that part. The same fields come through here, but again, the only field changed was status, so that's the only delta change published in this update event. Let's refresh this case object though, just so you can see in the UI, see I'm not faking it. You can see that the status has been updated to part received, which is great. And then you can also see that we have our chatter post letting me know as the case owner that this part was received, it's ready for installation, follow up with Astro to schedule an appointment. So what we've seen here is an end-to-end flow of a change event from Salesforce generated from the UI or the API, whatever it may be, being subscribed to by an application running on Heroku, but maybe that's running on-prem or AWS, whatever the case may be, processing that data event and triggering some downstream workflows. In this case, it was kicking off an order fulfillment process, making sure that part was in the inventory, in the warehouse, so that it could be delivered to the requester of that part. The part supplier then published a platform event back into Salesforce to trigger an internal Salesforce process, which was the process and the Apex trigger. We didn't talk about what the Apex trigger did though. That created this parts record. So we updated that inventory. So now we can see that CPU 7000 part is in our Salesforce catalog. And we're ready to install this. We're ready to get Astro back on the road, or back in the skies, if you will. So now, let's pop back to the presentation real quick and talk about one of the most exciting slides for me is our roadmap. So very excited to announce that Change Data Capture is going to be GA'd mid-winter 19. And today, if you sign up at DE org, you can try out CDC. All pre-release orgs have it. DE orgs will be upgraded with the winter 19 rollout, so you'll be able to use it in your playgrounds. We also have a trailhead coming out in November for Change Data Capture, so you can really dig in and learn how to use this, learn how to subscribe. That's coming in winter 19. Spring 19, the next release, we're looking to add sharing support. So how do I apply sharing rules to these change events based on the parent entity, so that I could have an end user subscribe to the change stream and only receive change events for the entities and records that I have access to via sharing rules. The other thing is virtual channels. This is really exciting. Imagine I want to create a sales app running external to Salesforce, and I want to compose a stream of accounts, contacts, leads, and opportunity updates. I want to compose those 4 different entity change types in one stream. That way I can make one subscription call with one client, receive all those data changes on one channel, and then have my app act appropriately and see those events as they relate to each other. Additionally, we're thinking about Apex triggers on CDC events, and this would really unlock a true asynchronous Apex trigger model. So you could move out all your processing from the transaction, remove some of your concern about limits, move all that processing, which should be asynchronous anyway, out of the transaction, be decoupled, put that in the CDC trigger itself, which is on the change event rather than on the change entity. Spring 19++, this is sort of 3+ releases away. We're looking at filtered subscriptions. How do I subscribe to a change stream and only receive events which match a certain criteria? Only give me case updates for high priority cases. Only tell me about opportunities if they're more than $100,000. Right? I don't want to filter out all the events on my client side and consume my limits, consume my bandwidth if I'm not taking action on these change events. How do I provide that criteria is what we're building. Also, we're looking at how do I do multi-org or even cross-org subscriptions between event streams. So if I have org A that's making a case change, how does org B receive that case change in real time and apply that change inside of it? These are longer-term aspirational ideas. Would love to hear your feedback. If you have specific ideas or examples of where this would help you, please see me afterwards or send me an email. And then the continuous theme is additional object support. We want to support all entities. The problem is there's over 1,000 developers checking in new entities every release to Salesforce. I've got half of my team on the second row, which is represented by 3 people. I've got 6 developers. If we spent all of our time, we couldn't even keep up with what the organization's doing, much less add support for all the existing entities. So how do I get internal teams to own the enablement of their entities is something I'm focused on. And the team is doing the enablement for the really hard entities that need that high-touch engagement. So we're really excited about the roadmap for change data capture. With that, I want to thank you for coming and also invite you to my session tomorrow at 9:15 or 9:30 in the Integration Theater, talking about connecting MuleSoft to change data events and platform events. Thank you very much.